Good morning. Today we are going to see the topic from computer graphics. In computer graphics, we are going to see the overview in graphics system. In graphics system, first we are going to see the video display devices. We know the basic primarily used output devices in graphics system is video monitor. The operations whatever in CRT monitor is having is used in the same VR monitors. So first, because of the CRT, whatever things which is used in the CRT, that is also same used in the VRT also, VRT monitors also. So first we are going to see what is CRT. CRT stands for cathode ray tubes. So now we are going to see the basic architecture of the CRT and how it is working. First, the cathode ray tube consists of a base. This is called as the base, and this base is connected with the connecting pins. It is called as base, and this one is called as connecting pins. And this one, it is called as the screen. And this screen, it is fully coated with the phosphorus. Fully coated with the phosphorus. Or you can say it as phosphor. And then this base is again connected with the electron gun. We say it as a electron gun. From this electron gun, it generates the electron beam. It generates the electron beam. And this electron beam is passed through this focusing anode as well as the magnetic coils. So, why we are using this focusing anodes and magnetic coils means in order to make this electron beam pass directly towards this phosphorus coated screen, we are using this focusing anode as well as the magnetic coils. This is called as the focusing anode. And I will show what is here is a magnetic coil. The electron beam which is generated from this electron gun will be traveling or traversing through this focusing anode as well as the magnetic coils. At some point it will go and strike the screen, this phosphorus coated screen at one point, which gives you a spot or which creates a light on the screen. So, if it is creating a light on the screen, there is one procedure to make a picture to appear continuously. So, to make this picture appear continuously, what we should do is that we should make this electron beam to appear again and again from here to this phosphorus coated screen. So, this type of refreshing of a screen is called as CRT refreshing. Now, we are going to see the internal architecture of the electron gun. So, the internal architecture of electron gun. This electron gun consists of two things. One is cathode, another one is control grid. This one is cathode and this one is control grid. So, from this only the electron beam is generated. How it is generated? Inside of this cathode, there is a coil. This coil of wire is also called as filament. When a heat when a current is passed to this coil or this filament, this will produce a heat on the cathode. It will produce a heat on the cathode. So, as a result of this, the electrons will be burned out. This burned out electrons are said to be as your electron beam. So, already in this cathode tube, because of the heat ejected by this cathode, here the cathode, that is the CR tube, will be fully filled with the vacuum. And this vacuum will be negatively charged. The vacuum, here the heat is there. When the heat is produced, automatically the CRT tube will produce a vacuum. That vacuum will be negatively charged. The heat produced, and because of that heat produced here, the electrons will be burned out, isn't it? So the electron beam will be generated. This will be positively charged. So as a result, this positive and negative combines together, it generates an electron beam and it makes it to fall on the screen of the phosphorus. So this focusing anode, as I told you already, this focusing anode is used to direct the beam. Not only the focusing anode, another one is there, that is accelerating anode. So what does this do means? It produces the positively charged particles. I have told you already that this vacuum tube will be producing the negatively charged particles, and here this electrons also will be producing the positively charged particles. To produce a high intensity of light, even this accelerating nodes anodes also is used to produce the positively charged particles. So these two together will generate this electron beam, and it directs the electron beam to project on this screen of the phosphorus, and it gives you the picture quality. And then there are two types of magnetic coils are there. One is placed horizontally and one is placed vertically. So one pair of magnetic coil is placed face to face or back to back. Another pair of magnetic coil is placed one at the top and another one at the bottom. So all this helps the electron beam to direct towards the screen and to give the better quality of the picture. Now we are going to see the raster scan. Raster scan display. So in this raster scan display, the electron beam from the electron gun, as it is generated on the screen, if this is the point of the screen, let us assume this as the screen. So what happens is that the beam will traverse row by row. The beam will traverse row by row. So wherever the picture is appeared, at that place the intensity will be more. The place where the picture is not appeared, the intensity will be very less. So here the intensity of each pixel of a picture will be set. The value for each pixel will be set. When we are drawing a picture, all the picture's pixel value or the intensity value will be already stored inside the picture memory. We call it as a frame buffer. So whatever picture you are going to specify, all those pictures pixel value, or you can say it as picture definition, will be mentioned inside the buffer frame or frame buffer. Inside the frame buffer. For example, if you want to draw a picture, say A, the light which is projected on the screen will be, as I told you before itself, it will be traversing row by row. So the place where the picture appears, the intensity will be high, or you can say that the intensity will be in the on position, and the place where the picture is not appeared, the intensity will be 0, or we can say it as off. If it is on, then it is set to as 1. If the intensity is on, we will say it as 1 bit. The intensity is not there, the picture is not appear over there, then we will say it as a 0, and the intensity will be in the off position. So there are two types of raster scan displays can be used. One is black and white raster scan display, black and white raster scan display, and another one is color raster scan display. In black and white raster scan display, it can use only two things, because it is black and white. It can use only two intensities. One is 1 and 0. The whole together, we say this as a 1 bit. So storing this 1 bit of information inside a buffer frame or frame buffer, then it is called as bitmap. I am repeating it again. When we are storing this 1 bit of information, when it is in the black and white raster scan display, the intensity is 1 and 0, and this 1 bit of information should be stored in the frame buffer. Then that buffer is called as what, Anitha? It is bitmap. And when we come to the raster scan display, we are having more than one color, because this raster scan display, it is also a color thing. So we will be having more colors. The intensity will be higher and higher and higher. It will not be 0, it will be much higher. So we can store this type of information, bit information, in color raster scan display. The bit information can be stored in the frame buffer, which is called as pixmap. If we are storing information of the bit in black and white raster scan display, then we have to store it in the frame buffer called bitmap. If we are storing an information of a bit in color raster scan display, we have to store in the frame buffer called pixmap. Next, we are going to see the random scan display. Random scan display. So that is a drawback in the raster scan display. What does the drawback means? It can draw only the straight lines. The raster scan display can draw only the straight lines. Whereas in random scan display, it's not like that. You can even also draw the curved lines. For example, we can say like this. If you want to draw a curved lines, you can use what? You can use random scan display. But whereas in raster scan display, we cannot draw a curved lines. So here also in random scan display, if the picture is like this, means the electron beam which is generated from the electron gun will fall on itself, only on the exact portion of the image, the light will be placed. Then we will be getting the picture fully. That is the advantage of this random scan display. Whereas it is not like that in the random scan display, the raster scan display. Because in raster scan display, the light from the beam will be traversing row by row. Each row by row it will be traversing, but here it is not like that. Exactly on the picture, the light will be appear. That is the random scan display. It is the main advantage. Next, we are going to see the color CRT monitors. In this color CRT monitors, the light which is generated from the light which is obtained from the electron beam will be creating different colors on the pictures. So, this color CRT monitors can be used by using two types of methods. One is beam penetration method. Another one is shadow mask method. In this beam penetration methods, the CRT monitor consists of only two colors. One is red, another one is green. So, in this CRT monitor, as I told you, the screen I told you, in this beam penetration method, the CRT monitor consists of two phosphorus screens. One screen is for red, another screen is for green. So, it depends upon the combination of the colors. Either this electron beam falls on the red, the screen will appear red. If it is falling on the green phosphorus screen, it will produce a green color display, or the combination of both the red and green forms orange and yellow color. So totally this beam penetration method can produce only two colors, orange and yellow, apart from this red and green. This is what we call it as what? Beam penetration method. The next one is the shadow mask method. In this shadow mask method, we have three electron guns. Three electron guns produces three electron beams. Why we are using three electron gun means for each and every color we are using one electron gun. One is for red, one is for green, and one is for blue. So when it falls on the screen, if red color is emitting on the screen will be displayed in red. If green color is if green color electron beam is emitted on the screen, then green will be displayed. If blue will be displayed. As we are having three colors, so the combination of any two or any three will be producing more colors. That is the main advantage of this shadow mask method. Either combination of red and green may appear, red and blue may appear, or green and blue may appear. Anything can appear. So these things will be producing different colors. That is the main advantage of this shadow mask method. It is mainly used in the raster scan display devices, and this one is mainly used in the random scan devices or displays. So now we are going to see the next topic, direct view storage tubes. So in this direct view storage tubes, the picture definition is directly stored as the charges. normal CRTs, each and every time the picture definition has to appear on the screen. It has to traverse through the picture definition, and from picture definition it has to go through the buffer memory, or you can say it as frame buffer, and then on the phosphorus. This happens in the normal CRT. Whereas in this direct view storage too, it directly, the picture definition is directly goes through the buffer memory and to the phosphorus protein. That is the difference. In normal CRT, it has to, picture definition has to go to the buffer memory, and from buffer memory it has to go to the phosphorus. But in direct view, the picture definition will be directly stored inside the buffer memory itself. So from buffer memory, directly the image will be displayed on the phosphorus. What is the advantage of this thing means? The picture resolution will be very, very high. Using this direct view storage view, the picture resolution will be very high. And what is the disadvantage means? If you want to remove, this is a picture. If you want to remove any part of the picture, you can, for example, I am saying that if you want to erase this part, you can't erase this part alone. If you want to erase it, you have to erase the whole picture. You cannot make any updates. That is the drawback in this direct view storage. If you want to remove this part means